Hello everyone, welcome to my channel. Today we are going to learn about a very important law in electrical engineering, Ohm's law, which is used in almost all electronic products and household appliances. Ohm's law was discovered by German physicist Georg Simon Ohm in 1827. This law describes the relationship between voltage, current, and resistance in electrical circuits. Simply put, Ohm's law tells us that voltage equals to current multiplied by resistance. More specifically, at a constant temperature, the current through a conductor is directly proportional to the voltage across the conductor's ends. Ohm introduced the proportional constant in the concept of resistance. So we can say current equal to voltage times constant, where the constant equal to 1 over resistance, or 1 over R. And then we have three formulas and to describe Ohm's law. The current equal to voltage divided by resistance, or resistance equal to voltage divided by current. Voltage equal to current times resistance. We can imagine the current flowing through a resistor as water flow. Water flows from tank A through pipes to the lower tank B. The pipes have valves controlling the flow rate. You can think of the pressure difference between tanks A and B as a voltage across a resistor. Narrow pipe is like a resistor, and tightening the valve is like increasing resistance. Like Newton's laws, Ohm's law is an empirical law summarized from experimental data, not derived from theory. Ohm precisely measures the relationship between current and voltage through the metal conductors, which is the IV curve, and thus deriving this formula. Today we will conduct an experiment to test the IV curve of a resistor and determine the resistance value. This is the circuit we built today and to measure resistance. First, let's look at this rheostat, which is used as constant resistor because the current doesn't flow through the black nodes. The voltmeter is connected in parallel with the resistor, and the ammeter is connected in series with the resistor. We are using a DC power supply that can display voltage and current values itself, so we don't need separate ammeters and voltmeters. However, to demonstrate how to use ammeters and voltmeter in this experiment, we have included them in the circuit. Now let's turn on the power supply and measure voltage and current. The power supply voltage will increase from 1.0 to 4.0 volts with a step size of 0.5 volts. Here we just show the voltage and current value of the circuit at each separate voltage steps. So when voltage 1.0 volts, the current is 0.04 amps. When the voltage is 1.5 volts, so the current is 0.06 amps. When the voltage is 2.0 volts, the current is 0.07 amps. When the voltage is 2.5 volts, the current is 0.09 amps. When the voltage is 3.0 volts, the current is 0.11 amps. When the voltage is 3.5 volts, the current is 0.13 amps. When the voltage is 4.0 volts, the current is 0.14 amps. Let's transfer the measured voltage and current values into an Excel spreadsheet and plot a fitted curve. We know this rheostat is a good metal conductor. As Ohm's law states, current and voltage show a proportional relationship, which is linear relationship. So we choose linear regression for our data. So in the final fitting formula, the reciprocal of the slope is the resistance. The slope here is 0.0364, giving us a calculated resistance of 27.5 ohms. However, the direct measurement with a multimeter gives 24.8 ohms. The absolute error between these two values is 2.7 ohms, which is quite small. The experiment gives a linear fitting intercept of 0.0018. Its physical meaning is that when voltage is zero, there is still a tiny current flowing, which can be approximated as current approaching zero. According to Ohm's law, theoretically, the intercept should be zero. This experimental result, I think, is very acceptable. To summarize, we provided the definition of Ohm's law, compared current to water flow, and noted that Ohm's law is derived from experiments, making it an empirical law, measures the voltage and current of a resistor. Finally, obtain the IV curve to determine the resistance and analyze the experimental results.